Okay, so for this problem, what we're doing here is it's asking, like you said, it's asking you to write it in terms of x. And what they've done is they've shown you we're going to call the, whatever you want to call it, the width of the rectangle, the length of the rectangle, x. All right. It looks like you're saying length x. Okay. Um, and then you got the semicircle. So what they're saying is how can you come up with ways of taking this and putting the whole thing in terms of x? Well, we know we've got this semicircle here. It looks like this, right? And if the width of the rectangle down here should be the same as the width of the rectangle up here, right? So if those are the same, whoops, didn't want to erase that semicircle. There we go. If those should be the same, then how can I, instead of calling this radius, how can I call this x? How can I rename it? Well, that's your first hint. If you want, stop, pause the video, and try to figure out from there. If that's not enough, well, here you go. Well, we know the whole thing here is x, and therefore half of this would be a radius, but it would also be 1/2 of an x. So therefore, in our formula, instead of writing radius, we could write 1/2 x. So when you go over here, this equation, instead of doing, so for your semicircle, it's going to be 1/2 pi, but instead of r, we're going to write 1/2 x squared. And then that would be your area of the semicircle. All right, so fantastic. Now we also need the area of the rectangle, right? If we're going to find the area of the whole window, that's just the area of the rectangle. It's in terms of x. We're great. Okay, so this is the area of the semicircle. Now we need the area of the rectangle. All right, so back to our picture here. We know the length is x, but what about the width? I need some way of getting that into terms of x. Well, I don't have any relationship. There's nothing I've got. So let's look back at the problem and see if there was any additional information. Oh, guess what? There was 40 feet of the perimeter. The perimeter of this whole shape is 40 feet. So let's see if we can write a perimeter equation. Write a perimeter equation for this shape. Well, let's see. How do you find perimeter of anything? You add up the sides. So if that's enough of a hint, stop the video there. Try it on your own. Otherwise, here we go. The perimeter is going to be, let's see, width. There's two widths, so we're going to have two w's plus an x. That would take care of the rectangle. That would take care of going from the kind of like around here, then around this side. So now the perimeter doesn't go across the middle to finish the rectangle, so we're done with the rectangle. Now we just need the other part. We need the circle part. Well, how do you find the perimeter of a semicircle? Well, once again, like we already figured out before, the radius is 1/2 x, so therefore the formula for a perimeter of a circle is 2 pi r. And then since we don't want the full circle, we want 1/2 of it, and that makes it kind of easy because those divide. So that's just going to leave us with pi r. Or I could write it the other way and write it 1/2 of a full circle perimeter, so those divide. And again, r is 1/2 x, so what we can say here is our perimeter for the shape is 2w plus x plus pi times 1/2 x. And now our whole goal here, well, we're building another equation, right? And we've got it almost in terms of x. We just have a perimeter and a width, and we knew the perimeter was 40, so we can go ahead and fill that in. I'm not going to rewrite the whole thing. I'm going to cheat. There we go. We know the perimeter is 40. And so now I have one equation here that's my perimeter that has a w and all x's. Then I need the area of my rectangle, which I know is just x times w. But I don't want this in terms of w, I want it in terms of x. So how can I use this equation, these two equations I should say, to get rid of my w's? And remember, the key thing, I want to keep the areas. That was the whole goal. My whole goal is to come up with an area. And I already have the first part here. The area of the semicircle I already got. So I'm going to do the area of the semicircle plus the area of the rectangle, but they all have to have x's. So how can I keep my area of a rectangle and not have x's in it anymore? No, I want w's. I want x's, I don't want w's. So how can I keep this area of a rectangle equation, just x times w, but not have w? Using the other equation. I'm going to leave it at that. Hope that helps.